Thought process.
Thought process, the best mistakes in human history. Most of the time, science works the way you'd expect. Someone identifies a problem, designs an experiment, runs it hundreds of times, and eventually arrives at an answer. Years of careful, methodical work producing an incremental advance. And then there's the other kind. The kind where someone leaves for vacation and comes back to find mold has contaminated their experiment, and that mold turns out to be the most important medical discovery of the 20th century. The kind where an engineer grabs the wrong part from a parts box and accidentally builds a device that is now keeping millions of people alive. The kind where a chocolate bar melts in a man's pocket and becomes a kitchen appliance found in over 90% of American homes. These aren't just fun trivia.
The accidental inventions on this list
Changed medicine, warfare, cooking, construction, and surgery in ways their discoverers never anticipated and could never have planned. 7 incredible inventions. 0 of them intentional. Let's go. Number 1. Penicillin. In the summer of 1928, a Scottish bacteriologist named Alexander Fleming left his London lab for a 2-week vacation without cleaning up his workstation. When he came back, he found that several of his Petri dishes growing Staphylococcus bacteria had been contaminated by mold blown in through an open window. He was about to throw them out when something stopped him. Around each mold colony, the bacteria were dead. The mold was producing something that killed them. That mold was Penicillium notatum. What it was producing was penicillin. Fleming published his findings in 1929, but had trouble isolating the active compound in a stable form, and the discovery sat largely dormant for over a decade. It was Howard Florey and Ernst Chain at Oxford who finally purified and tested penicillin in the early 1940s, demonstrating that it could treat bacterial infections in humans. By the end of World War II, mass production was underway, and soldiers who would have died from infected wounds were surviving. The World Health Organization estimates that penicillin and the antibiotics derived from it have saved between 80 and 200 million lives since their introduction. That number is almost impossible to hold in your head. All of it traces back to a contaminated petri dish and a man who decided to look before he threw it away. Number 2. The microwave oven. In 1945, an American engineer named Percy Spencer was working at Raytheon, testing magnetrons, the high-powered vacuum tubes at the heart of radar systems. He walked in front of an active magnetron one day and noticed that the chocolate bar in his pocket had melted. Spencer was curious enough to try an experiment. He held a bag of popcorn kernels near the magnetron. They popped. He tried an egg. It exploded. Within a year, Raytheon had filed a patent for a microwave cooking oven. The first commercial unit shipped in 1947. It stood nearly 6 feet tall, weighed 750 pounds, cost around $52,000 in today's money, and had to be plumbed with water for cooling. It was sold primarily to restaurants and ocean liners. It took another 2 decades of engineering to shrink the device to something that fit on a kitchen counter and cost less than a television. By 1975, microwave ovens were outselling gas ranges in the United States. Today, roughly 90% of American homes have one. The entire frozen food industry was transformed by it. It is one of the most significant kitchen technologies in history, and it started because a man's candy bar got warm standing next to radar equipment. No. 3. X-rays. On November 8, 1895, a German physicist named Wilhelm Röntgen was experimenting with cathode ray tubes, glass tubes that shot beams of electrons when a current was applied. He had wrapped his tube in black cardboard to block any visible light. Across the room, a screen coated with a fluorescent material started glowing. That should have been impossible. The cardboard was blocking all visible light from the tube. Whatever was making the screen glow was passing through solid cardboard. Röntgen spent the next several weeks working in near-total secrecy, trying to understand what he'd found. He discovered the mystery rays could pass through paper, wood, and human tissue, but were blocked by denser materials like metal and bone. He named them X-rays because X is the mathematical symbol for an unknown. The first X-ray image he captured was of his wife's hand, showing the bones of her fingers and her wedding ring. When she saw it, she reportedly said it looked like she was seeing her own death. Within months of Röntgen's publication in January 1896, hospitals around the world were using X-rays to locate bullets in soldiers and identify broken bones. He won the first Nobel Prize in Physics in 1901 for the discovery. The entire field of diagnostic radiology, which now includes CT scans, mammography, and fluoroscopy, traces directly to a glowing screen that had no business glowing. Number 4. Teflon. In April 1938, a DuPont chemist named Roy Plunkett was trying to develop a new non-toxic refrigerant. He was working with tetrafluoroethylene gas, storing it under pressure in small cylinders. One morning, he opened a cylinder to run a test, and nothing came out. The gas was gone. Instead of moving on, Plunkett cut the cylinder open to find out what had happened. The inside was coated with a white, waxy, slippery powder. The tetrafluoroethylene had polymerized. The molecules had bonded together into long chains, creating a substance that had never existed before. That substance was polytetrafluoroethylene. DuPont trademarked it as Teflon. Teflon turned out to have a remarkable combination of properties. It was chemically inert. Almost nothing would stick to it or react with it. It could withstand temperatures ranging from cryogenic cold to well over 300 degrees Celsius. It had an extraordinarily low coefficient of friction. The first commercial application wasn't frying pans. It was the Manhattan Project, where Teflon was used to coat pipes and valves handling corrosive uranium hexafluoride. After the war, it found its way into aerospace, medical implants, industrial seals, and eventually, in the 1960s, the non-stick cookware that made it a household name. The non-stick pan on your stove is a Cold War-era industrial accident that spent its first years enriching uranium. No. 5. The pacemaker. In 1956, an American electrical engineer named Wilson Greatbatch was building a device to record heart rhythms. He reached into a box of resistors to grab a component and pulled out the wrong one. A 1 mega-ohm resistor instead of the 10,000 ohm resistor he needed. He installed it anyway, switched the circuit on, and instead of recording a heartbeat, the device started generating one. A steady, rhythmic electrical pulse, about 1.8 milliseconds on, 1 second off. Almost exactly the timing of a human heartbeat. Greatbatch recognized immediately what he was looking at. Heart block, a condition where the electrical signals coordinating the heart's chambers are disrupted, was killing tens of thousands of people a year with no effective treatment. The wrong resistor had built a device that could replace those signals. Working in his barn for 2 years on a $2,000 budget, Greatbatch developed a fully implantable pacemaker. The first one was implanted in a human patient in 1960. The patient lived for 18 months, long enough to prove the concept. The devices that followed kept people alive for decades. Today, there are roughly 3 million people walking around with pacemakers. Around 600,000 new devices are implanted each year globally. The industry built on that one wrong resistor is worth over $4 billion annually. Greatbatch later said, "I seriously doubt that we would have had an implantable pacemaker as soon as we did if I had grabbed the right resistor." Number 6. Velcro. In 1941, a Swiss electrical engineer named Georges de Mestral went for a walk in the Alps with his dog. When they got home, both he and the dog were covered in burdock burrs, the small, spiky seed pods that cling to fabric and fur. Most people pull them off and forget about it. De Mestral put one under a microscope. He found that the burr was covered in tiny hooks that caught on the loops in fabric and animal fur. The attachment was strong enough to resist pulling, but flexible enough to release cleanly when peeled away at the right angle. It took him a decade to figure out how to replicate the mechanism in manufactured materials. The breakthrough came when he discovered that nylon, when sewn under infrared light, formed the right kind of rigid loops on one side. He paired that with a strip of nylon hooks and filed a patent in 1955. The name came from the French words velours, velvet, and crochet, hook. The fashion industry initially dismissed it as a gimmick. NASA embraced it first, using Velcro to secure equipment in zero gravity aboard spacecraft in the 1960s. That adoption and the visibility it brought turned skepticism into a global market. Today, Velcro and its competitors produce roughly 60 million meters of hook and loop fastener every year. It's in shoes, medical devices, military equipment, spacecraft, and the straps of virtually every backpack on the planet. All because a man with a curious mind came home from a muddy walk. Number 7. The Post-it note. In 1968, a 3M chemist named Spencer Silver was trying to develop a super strong adhesive. What he got was the opposite. A pressure-sensitive adhesive that was strong enough to stick things together, but weak enough to peel off cleanly without leaving residue. It could be repositioned over and over without losing its grip. Silver had no idea what to do with it. For 6 years, he promoted the adhesive internally at 3M, describing it as a solution without a problem. Nobody bit. The problem was found in 1974 by another 3M employee named Art Fry. Fry sang in a church choir and was frustrated that his paper bookmarks kept falling out of his hymnal. He remembered Silver's adhesive from a seminar, coated a strip of paper with it, and stuck it in his book. It stayed put. It came off clean. It left no damage. The Post-it note went through 3 more years of product development and a cautious, regional test launch before 3M released it nationally in 1980. It became one of the company's best-selling products within 2 years. Today, 3M sells Post-it notes in more than 100 countries in over 4,000 varieties. The humble sticky note, born from a failed attempt to make something stronger, is one of the most recognized office products in the world. What every accidental invention has in common: 7 incredible inventions. A contaminated petri dish, a melted chocolate bar, a glowing screen across a dark room, a cylinder full of the wrong powder, the wrong resistor from the wrong box, a dog covered in burrs, a weak adhesive nobody wanted. The obvious thread is luck. But that's not really the story. Luck is everywhere. Most people walking past that glowing screen would have assumed the equipment was malfunctioning and moved on. Most chemists opening an empty cylinder would have marked it defective and ordered another. What separates these inventors isn't that they were lucky, it's that they were curious enough to stop and ask why. Fleming could have cleaned up his petri dishes and left. Röntgen could have switched off his tube and called it a day. Greatbatch could have grabbed the right resistor. Every one of these discoveries required someone to slow down, notice something unexpected, and treat it as a question rather than an inconvenience. That's the real lesson from accidental inventions. The world is constantly producing signals. Most of them go unread. The people on this list were the ones who read them. If this video gave you a new favorite story to tell at dinner, drop it in the comments. Which one got you most? I read every one. And if you want more of this, the history, the science, the moments that changed everything, subscribe and hit the notification bell. New video every week.
I'll see you in the next one.